Hello everyone. For this video, we will be looking at how do we determine the domain of a function and also the range of the function. Now, a quick look into this chapter is that if we are looking for the domain, you can think of it as if you are looking for the x value of the function. If we are looking for range, you can imagine it looking for the y value being where some graphs, they actually state that fx equals to y, okay? So the function can easily be replaced with writing it as y, okay? And also the domain of fx can equals to the range of your inverse f. Then vice versa, the range of fx will also equals to the domain of your inverse f, okay? So looking at one of the example questions that we have here, first question here is they are asking to state the range of g. The function g, we will only look at this part here, okay? To find the range of g, what you need to know is you can actually just straight away substitute 0 into the x. If after substituting 0 into x, 0 minus g minus 9, okay, you would have gotten a value of -9. Now, the range for g in this case would have been anything more than 9, -9, okay? Now, the long explanation to why gx is actually more than -9, you would have to look at the entire question. If you were to look at this entire question, you would notice that gx is actually a quadratic equation that would look like this, since it is a positive quadratic equation. And you would also notice that -9 is its y-intercept, okay? -9 is the y-intercept, so it would look something like this if we were to plot it on a quadratic graph. If we were to, if we were to plot it onto a Cartesian plane, okay, with -9 being the y-intercept. Now, on the second part, this here mentions that x has to be more than 0, meaning to say we will disregard every other part over here and only look into the part where it is when x value is more than 0, okay? So this is the only part of the graph that we will consider. Therefore, the range of it will naturally be anything that is more than -9, right? The second part. In the second part of the question, they're asking to find the domain of gf. So we know that gf is actually a compound function. Now, the trick is when they are compounded together, the range will overlap on each other. If you notice, for gf, it's simply putting f into g, right? Which means your function would be 5x minus 2 square minus 9. Now, since that fx is in the function of gfx, what it would also mean that the the domain has been imported over. This equation now can only start at more than 1, okay? This means that the domain of gf has, the x value has to be more than 1, which you would leave your answer as like such, x more than 1. And you would be done with the equation. Okay, now let's look at our next example question. The function g is defined for x when it is more than -1 by gx equals to an equation here. The function here, h, is kx plus 3, okay? These are the two equations that we need to look at for this equation, where k is a constant. State the domain of hg. Again, hg is a compound function, isn't it? Now, again, if we were to put g into h, from what we learned in the previous question, the domains get imported over. So the x value for domain of hg has got to be the only one that has a limit in the first place, x more than -1/2. All right, simple as that. Now, looking at the third question, find the range of f. Again, if we're asked to find the range, we can actually substitute 0 into our equation. 2, 0 plus 3 square the whole thing, you would have gotten 9. Okay, same logic as the question that we attempted earlier. If we were to plot this graph out, okay, it would actually look something like this, where you have positive 9. Okay, positive 9, then we will only take positive 9 onwards into account. Okay, so the range for f has got to be, the range for fx has got to be more than positive 9 as well. Since we've found the range of f according to this rule over here, where the range of fx is actually the domain of f inverse x, if the question asks to state the domain of f inverse, okay, then the domain would naturally be the same value as your range. All right. Looking at another example question, the function f and g are defined for x more than 1. Okay, so for this question, they stated that both of them has to be values of x more than 1, x more than 1. All right. Find an expression for f inverse stating its domain. Now, to find the inverse of fx, what we're first going to have to do is let y equals to the equation over here. Okay. After letting y equals to the equation, we're going to move everything over to make x the subject. Okay, so you have y over 9 would have equals to the square root of 1. Square root bring over would have equals to square. Okay, and then you would be left with x plus 1 on the right hand side. Bring the bring the minus 1 over, you will get a plus 1. Then this equation will equals to x. Now, after this, having said that, the inverse of f is actually x over 9 square plus 1, right? Now, the question is asking us to state its domain. Stating its domain meaning to say we're looking for the x value, isn't it? Looking for its x value is looking for the domain of an inverse is as if we're looking for the range of the fx. Okay, so let's say we're looking for the range here. All we had to do was substitute 1 into it, 9 square root 1 minus 1, okay? Then you would end up with a square root of 0. Square root of 0 multiplied by 9, the range would have been 0 in this case, okay? So the domain for f inverse x, okay, would have been when x is more than 0, okay? Okay, two more examples. Function f and g are defined for x more than 0, okay? More than 0, x more than 0. Write down the range of g. Again, we'll ask to find range. So substitute the 0 into this. 2, 0 square plus 3. 0 square times 0 is still 0. So the range would be 3, isn't it? The range for g, sorry, not f, for gx has to be more than 3. Okay, if we were to plot this into a graph, then we could tell that this is again a quadratic equation. Plot it like so. When x is more than 0, so you will intercept at the y-axis at 3, positive 3. And therefore the range for g from here onwards, similar to the questions above, would be more than 3. Okay. Now, one last question here. It is given that fx is equals to 3 exponential to the power of negative 4x plus 5 for x is all real values. state the range of f. Stating the range is again looking for the y value, isn't it? Looking for the y value. So in this case here, there are all real values. To answer this question, it would be better if you understood how the graph looks like. If you do not know how to use it, do not know how to find it, you can always try a website called Desmos, and you can plot the graph exactly into the calculator itself. Now, what an exponential graph would look like is, it would look something like this, okay? Something like this. But in this case, since it is +5, it would have shifted upwards, okay? Shifted upwards by 5, and it will start something like this, okay? Where it is 5. So the range of f has got to be also more than 5. The range of fx will also be more than 5. You can tell from the y-intercept here. Lastly, find f inverse and state its domain. So actually, we don't even need to find the f inverse. We can just state its domain. Since we know that the range of f is more than 5, the domain of f inverse will also be more than 5. And that's it, guys. And that will be it for this video. Hope you guys find this video helpful.